Hi folks, I'm Sean Horn at Chef. I work in the CSE team, and this is Noah Kantrowitz. He's working at the Python Software Foundation, doing PyCon stuff, running an infrastructure team there. Now works at Balanced, did work at Chef, a maker of things, right? Yeah, so like, It's a tiny.
See my speaker display.
It's a tiny pod. So he's going to be talking about like reusable cookbooks and like how do you engineer the cookbook so that can be quite a bit easier, like writing for testability or something, right? So please take it away, Noah. Thanks.
All right. Thank you to Sean. So, like he said, my name is Noah Kantrowitz. I'm the infrastructure lead for the Python Software Foundation and the tech lead for PyCon. I work for Balance Payments, which does marketplace payments, but I'm not here to talk about that. I used to work for Opscode, and more generally, I work on the Chef community as a whole, and I really like making things. So really, this talk is about three things. What is a cookbook? What is a reusable cookbook? Why would you want to make reusable cookbooks? And how can we make reusable cookbooks? So in the beginning, there was Chef. Chef was a thing, it was good. People wrote cookbooks, and then sometimes people might post them on GitHub or to a blog, but overall, people just sort of wrote their own thing. Chef was a framework to write your stuff, and that was just kind of it. But then it got more complicated. We tried to share cookbooks, originally through the Chef repo, and then later on through the community site, and we tried to make these cookbooks that multiple people could use to run their business. And due to this, there was an explosion in the complexity and the number of use cases that every cookbook had to handle. But let's rewind. First, what is a cookbook? So a cookbook is a description of a piece of infrastructure. That means it is a noun. Not just that cookbooks are nouns, but cookbooks describe nouns. A cookbook is a thing. There is a cookbook. It is called Apache 2. It installs Apache 2. It makes that server be Apache 2'd. They are an abstraction boundary. Every cookbook says, hey, after you run this recipe or whatever, you run the default recipe or you run these recipes in order, here is what will be done. You don't need to worry about the internals. That's behind the abstraction boundary. Just if you do it, here's what I promise the server will end up looking like. And so it's a package that represents something in your infrastructure. But when you think about it, we actually have several things that accomplish that goal. So we have roles, cookbooks, recipes within cookbooks, and individual resources, including LWRPs. Each of those is a kind of abstraction boundary that says, hey, when you run me, I will end up looking like this. And we build the larger abstractions on top of the smaller ones. But they're not all equal. Roles are purely declarative, so they can't be any executable code. You can't vary them in any way, and they are unversioned, although in future versions of Chef that may change. And they can only be composed of recipes and other roles. Cookbooks, similarly, are effectively declarative. They can only be composed of of recipes. Recipes can't be fully isolated because if you include only one recipe, all the attributes and other files get activated. And resources are way down at the bottom, and they're either LWRPs, which are fairly limited, or they're heavyweight resources or class-based resources, which are super verbose. So we have sort of four different things that all serve as this function of abstraction boundary, but they all do it in very different ways. And now that I've mentioned the word abstraction, you all know the next thing that someone is thinking of already. So we have all these different things, and they are all leaky abstractions in different ways. So for those not familiar with the term, leaky abstraction was popularized by Joel Spolsky. It's the tendency of complex abstractions to require that you understand the internals of the abstraction before you can use it, that the details of the implementation leak out into its usage. This is very common in complex computer systems. The canonical example is things like IP networking, where the internal details of IP leak into TCP. IP is unreliable transport, TCP is reliable transport. But the internal details of the fact that it's an unreliable transport under the hood leak out, and when you're writing complex TCP servers, you have to understand that and you have to accommodate for that. The most important side effect of this is the enormous cognitive burden it places on people using reusable cookbooks. That if the abstraction boundaries leak more than a little bit, then you have to understand how they are built. You have to go read the code. How many people here have read the code of a, quote, reusable cookbook? Everybody. So you can't really just use them. It's not like, a library. Very few people, really poor example, but let's say OpenSSL. There's probably not a lot of people that have read the OpenSSL code. Hi, Jesse.
I was just going to give you a hug.
So, like I said, enormous cognitive burden, and we really want to avoid that whenever possible. We really want people to just be able to grab this thing and say, okay, I understand what contract this provides. I want that contract. Here's how I use it. Done. Don't have to worry about the internals. So we started by defining a cookbook as an abstraction barrier. And as we've written more and more of these reusable community cookbooks, they've leaked more and more and more. And now we're left with a very tangled mess of complicated cookbooks. As you try to patch it, you add a new special case, but every time you add a new special case, you're leaking in other places because all of a sudden now you have to be aware that those cases exist and when you need them. So we can keep doing that, but it only goes so far. And I think basically everyone has agreed that we're reaching about the upper limits of what everyone can sustain on this. But I think there's one word that can sum up our troubles, and it's not just reusability, it's extensibility. What we want isn't necessarily reusable cookbooks. We don't want a single cookbook that covers everyone's use case. We want a single cookbook that is extensible enough that you can make it match your use case. It's a subtle difference, but I think it's very important to keep that in mind when trying to design these things. So there's three main strategies right now for writing reusable or extensible cookbooks. If you saw Paul's great talk right before this will all look very familiar. So the first one is you fork the cookbook. You grab the cookbook, you take it from GitHub, and you change it. All of a sudden, it matches your use case. Super simple, super easy, very, very difficult to maintain in a complex ecosystem. You usually fork the cookbook, and that's it. Maybe you submit that patch back upstream, maybe it gets accepted. In the interim, you have to deal with, it's a forked version while you're waiting for the patch to get merged. If you can't submit it because your use case is too specific, then you have a permanent fork. All of a sudden you have to choose whether you're going to track upstream or you're not going to track upstream. That in and of itself is a full-time job. So forking, not always a great option. Another option, wrapper cookbooks. These have become very popular lately. I'm happy or maybe sad a little bit to say this is something I have pushed a lot of people towards. It's a structured way that you can append or prepend different instructions on top of an existing recipe, but that's pretty limited. Appending and prepending gets you pretty far, but sometimes you need to change stuff, and wrapper cookbooks don't allow that. You can only put stuff, you put something before, you include recipe, you put something after. That's your only options. And then there's Chef Rewind, or monkey patching, which does allow you to change stuff, but in a very fragile way. You are incredibly tied to the internal implementation behind that other abstraction. That is the mother of all leaky abstractions. So you end up with Chef Rewind, you're very, very tied to their implementation. If you wanted to override a config file, you don't just worry about the fact that you want to override a config file, you have to worry exactly how the upstream cookbook implements that config file. Is it a cookbook file? Is it a template? Was it copied in one place? Was it linked? Whatever. And that's really breakable. So I want to introduce a fourth way. Inheritance, object inheritance. So Ruby, object-oriented language, resources are classes. Resources can be subclassed. They can be inherited from one to the other. Yes, inheritance, I'm sure some of you are already thinking, is also a very leaky abstraction, but unlike Chef Rewind, it allows us to create very structured leaks. So you only have to worry about the pieces that you want to worry about. It allows us to give symbolic names to pieces of code. We normally call these functions. They're pretty cool. You can call them. You can override them. You can call superclass versions of functions, things like that. But there is a downside. Unfortunately, using inheritance between resources as an extension mechanism means we can't use LWRPs. This is being pursued for a future version of Chef, but currently LWRP class creation happens outside of the DSL, so this means we are going to have to talk about writing real heavyweight class-based resources. But let's stop for a moment. So we've been talking a lot about writing extensible cookbooks. I believe extensible cookbooks are awesome. I think that we should get to a world where lots of people can just use these, but that doesn't mean everyone should be writing them. You should very much think about, should I tackle writing a reusable cookbook? There's a bit of a meme going around for the last couple of years about this idea of a 10x engineer. I won't get into how terrible that is, but I want to co-opt the term. 10x cookbook. Writing a reusable cookbook is minimum 10 times more difficult, more time-consuming, and therefore more expensive than just writing a cookbook for what you need. You should consider very critically if that is something you're okay with. Now, I really love open source communities, so I think that there are times where it is okay to spend a lot more time, money, and effort building something so other people can use it. But you should not always jump at that. There should be no stigma in saying, I'm going to write a cookbook that does exactly what I need. It is much faster, it is much more maintainable, and it is much simpler, much less error prone. I can go on and on. Do not tackle writing reusable cookbooks unless you are willing to get into this. Also of note, having a simple version, saying, oh, I'm going to do that first, and then I'm going to turn this into a reusable cookbook, doesn't work. You end up with this idea of, I'll just add special cases, and then you've lost the game. So really, really think about this, and don't jump into writing reusable cookbooks unless you are prepared to treat this as you would any other open source project. So with that all said, allow me to introduce Poise. So I've spent the last 6 months writing a set of chef cookbooks and libraries and patterns to make writing extensible cookbooks better. Now this, I commonly apply this to writing community reusable cookbooks, but we also at my company use this internally. We have some extensible cookbooks that are internal use only, like our internal application cookbook. It's not something anyone else is going to use. It only matters to us, but we want to extend it because we have slight variations between apps. Some depend on different libraries, some requires a worker process, things like that. So Poise is composed of 3 primary pieces. It's got helper functions, DSL extensions, and then outside of the code, a set of common reusable patterns for how to build these cookbooks. And really, my dream in the end is to see Chef as a set of reusable building blocks to build application platforms. What I want is this mythical set of Lego bricks that you can plug together and just get a platform. I'm sure everyone here also would love that. We're a long way away from it, but I think this is the right way to build it inside Chef. So a quick concrete example. So I have a Jenkins cookbook. This is not the upstream Chef Incorporated Jenkins cookbook, but it's based around resources. So I have a master resource called Jenkins. That is the thing that installs and configures Jenkins. This is what you might traditionally think of as a recipe. But instead, it's a resource. And that means that I could, for instance, install 2 copies of it or 2 different versions at the same time, which I do frequently. I also have resources called Jenkins Job, Jenkins Credential, and Jenkins Plugin. I'm guessing you can all probably figure out what those do just from the name. They provide encapsulated abstractions for each of those things. And then on top of that, we have a different cookbook. So Jenkins is a relatively low-level model. It's what would generally be referred to as a library cookbook. It directly models Jenkins, whereas the CI cookbook models our continuous integration system, which, while it uses Jenkins, is much more specific to our needs. So we have CI job, which inherits from Jenkins job, but it adds a whole lot of stuff. It adds different defaults, it adds extra config variables, things like that. We also have CI pipeline, which is just starting to look at this sort of Lego brick abstraction that's built on top of things like CI job and Jenkins plugin and stuff like that, but it provides a higher level interface that strings together multiple Jenkins jobs, so my developers don't have to think about that. All they think about is, hey, I need a CI pipeline, here's the Git repository, and I'm off to the races. And we actually even have an extension of that, which is in a wrapper cookbook, which is further customizations for specific teams. So let's look a little bit about how to use Poise specifically. So the basic structure is you open a library file, you put in whatever copyright header and requires you need, and then you write a class. I promise they don't bite. You were lied to when people told you you didn't need to learn Ruby to use Chef, but I promise it's not very much Ruby. All classes go in the Chef namespace because that's how Chef works. Every resource is actually built out of 2 different classes. There's the resource and the provider. That's the R and P in LWRP. They are actually 2 separate classes. They do generally need to be named the same thing, but all they do is inherit from their respective base classes, and you're off to the races. A quick side note, when I showed you the names directly map into how you use the resource from the Chef Recipe DSL. This shows the mapping. So anytime you have a capital letter, that becomes an underscore, basically. This is mostly important. Do not put HTTP in all caps or other abbreviations, or you'll be very confused when your resources are not found. So we have our classes. The next thing we want to do is grab the Poise helpers. You might have noticed that you don't inherit from Poise. You inherit directly from the Chef resource and provider class. Poise is built as a system of mix-ins. So what you do is you include Poise into your class. There is a single master Poise module that gets you all of the helpers. If you go into the documentation, you can also see that you can include specific helpers one by one if you absolutely need to. So what do these helpers do? So the most simple of them gives you something very similar to the lightweight resource DSL. This will look very familiar to anyone that's written in LWRP. You get action, you get attribute, and those map down into the same things as they do in LWRPs. Of note, default action does exist, but you probably don't need to call it. The first argument to action will become the default, which is almost always what you want. But we've also got some extra helpers. So for instance, there's a new type of attribute called an option collector. Anyone who's played with the application cookbook has seen a very early pattern of this from 2.5 years ago. But this allows passing a set of key value pair arguments into your resource in a very chef-y declarative style. So you can see an example of usage down below where you're passing the key foo and the value bar, and that'll be converted to a hash internally. Another helper that Poise adds, lazy defaults. So one problem with resource-based or class-based resources is when the resource definition is compiled, when the actual class is loaded, Chef isn't really ready yet. Library loading happens really early on, so the node object doesn't exist. Attribute files haven't been compiled. Most stuff hasn't even been loaded yet. So we can't make defaults that depend on things that happen way later. The solution to this is I added a new function that works very similarly to the lazy loading stuff in Chef resources. Lets you use them for defining default values. Another helper, template content system. This one's a little bit harder to explain, but very, very useful. You can mark an attribute as being a template value. And this then means that you can either provide a template source, the same way you would on a template resource, or you can directly provide content. And in either case, it'll still bake down to a string. So you can have unified code paths between template-based content and direct file-based content. This is really useful when you start having nested resources where you want to be able to support people using it directly with a template, but some people might be calling it from within bigger, more complex abstractions. And for them, they don't want a template. They just want to provide you with some bytes that you will write to a file because they're doing more complex stuff. They have their own templating system, whatever it is. So the template resource, the template content attribute helpers give you a very simple way to do that. So that covers the resource side of the helpers. In the provider, one thing I have not done is re-implemented the action method from lightweight providers, mostly because this is all that you need. Def action underscore and then the name of the action. That is literally all that action helper does. I think I counted it's exactly the same number of characters, or certainly close. So don't bother with the action helper, just define a method. Another helper that's exposed within providers is notifying block. This is very similar to use inline resources in LWRPs, except it's tightly scoped. So whereas LWRPs, if you define use inline resources, it applies to your entire action method, or all of your action methods. Notifying block is scoped to just that block. So whatever you put inside the block, you can use whatever Chef Recipe DSL you want, and before that function returns, those resources will have been compiled and they will have been converged. And it also handles propagating notifications out in a similar way to use inline resources. One addition beyond use inline resources, it correctly handles delayed notifications actually being delayed until the end of the converge cycle. And the last helper in providers is include recipe. This slide probably looks really silly because all you'll probably already know how to use include recipe, but if you ever tried doing that inside a lightweight provider, you found it doesn't work. Now it does. Pretty simple. So let's pull all of this together a bit. Sorry for some of the abbreviations, but got to fit on a slide. So we are defining a resource called foo. We pull in the Poise helpers via the mixin. We define an action called one. We have two attributes called package and version with no particular stuff attached to them. And we define our provider. It has to define an action method. So it has action one. We have a notifying block. So you'll see here, I don't usually directly use the recipe DSL inside notifying block. So the reason for that is I want to allow people to inherit from my provider and extend or change some of these methods. And I'll get to an example of that in a minute. So you can see we have two methods called install package and write config. So those are just standard methods defined on the provider. No special magic. Like I said, they don't have to be there. You can just use the raw chef DSL there. You can paste your current recipe inside the notifying block. It'll just work. But if you do this thing where you break stuff into individually named methods, it provides more formalized points for people to extend it. So whereas this is the sort of base version of install package, you can see we're installing the package requested at the version requested. Super simple. But let's say I wanted to subclass the provider. I could override this to call the superclass, change the package name to my thing. So let's say we compiled our own version of this locally and we want to use that instead. And then I return the original one. So this is a structured way of doing something very similar to Chef Rewind. But instead of depending on the original name of the package, which as you saw was user defined and therefore very difficult to fit into a Chef Rewind system, I'm using the function name as a sort of formal extension point. And you can sort of nest these. You can have subclasses declare their own step methods and things like that. So, and then finally, let's look at a few next steps of what's coming up with Poise. So one thing I did not cover at all, but if you've played with some of my Poise cookbooks you've seen, is the Subresources system. Unfortunately, it's too complicated to fit in a 40-minute talk, so I've had to leave this out. But Poise does have a system for having child and parent relationships between resources, where the children can reference their parent. This leads to very natural object-oriented modeling for things like database users, where the user belongs to a database server. Or Jenkins plugins, like I mentioned. If you have multiple Jenkins servers, you want to know which Jenkins server the plugin should get installed to. And the Subresources system gives you a very nice DSL both within the provider code and within your recipe code. Cookbook tiers are another thing that should be factored into this a little bit more detailed. As you start to write more and more cookbooks, you'll see them starting to split out into a few layers. Sort of at the really top levels, we've got things that people are somewhat familiar with, like role cookbooks and environment cookbooks. At the really low levels, you've got these sort of library cookbooks, which very faithfully model an underlying system. So like the Jenkins one, where the resources in that are based on what Jenkins offers. There's not a whole lot of editorial control there. And then you've got sort of these middle tiers, which allow you to build more complex abstractions, and those are the sort of application-y cookbooks. And there's a few other helpers that aren't in Poise itself because they're either too complex or not quite related to Poise itself, but you should know that they exist. So Poise Proxy is a cookbook that offers a generic resource that you can either use directly or inherit from to provide a abstract version of an HTTP proxy server. This is mostly useful for things that need HTTPS. If you want TLS termination, that's a really common pattern in these little tiny cookbooks. I want to run some web app, and then it needs TLS. Poise Proxy lets you do that in a generic way. It automatically supports both Apache and Nginx. So you, as the author, don't need to worry about the end user gets to control which one they actually run, which is super nice for admins that don't want one of those. Poise Append is another helper. It's mostly designed for writing environment cookbooks. If you want to store config settings that vary per environment, but for a variety of reasons you don't want to use chef environments for that, mostly because they're very heavyweight and they can't overlap. You can look at Poise Append. And finally, Poise Service is something that's still very much in progress, but similarly, whereas Poise Proxy lets you write an abstract representation inside, you just say, I want a proxy server that should look, should proxy to port whatever, and then way down the end user, they get to say, I want to use Apache for that, or I want to use Nginx for that. Poise Service is a thing I've been working on to try to do that for service management, because there's an awful lot of reusable cookbooks that are really reusable as long as you want to use Runit, which is awesome, and I usually don't. So what I would much prefer to see is in a reusable cookbook, you declare, hey, I have a thing that needs to be running, and it is up to the final sysadmin to say which service that actually runs on. If you're interested in this, check out Jordan Sissel's Please Run project. It's what I've been playing with a lot to try to figure out how to do this. And yeah, also some stuff that will be coming soon in Poise itself. A very common pattern I found is to have resource attributes that default to node attributes. So I'd like to see some helpers for that. I'd like to see notifying block unified with John Kaiser's resource group system. We've been talking about that a lot today and over the last couple weeks to figure out how we deal with resource groups of various types. So notifying block is one type of resource group, but there are maybe others. And if we can build a shared API for that. And finally, I'd really like to see some more formal functions for dealing with dependency injection. So whereas before what I was showing you is using subclassing as a really cheap ad hoc procedural dependency injection framework, I think it'd be cool to see Rails, for instance, has some examples of how to build a dependency injection framework in Ruby that doesn't completely suck. So that's just a little bit of what's sort of next on my list as far as what I think needs to be done for writing reusable cookbooks. But I'd really love to hear from all of you about what pain points you've found. And finally, keep writing cookbooks. Keep writing good cookbooks. Keep writing bad cookbooks. We all, myself included, are only just starting to figure out how to do this particularly well. So we just have to do it a whole lot more. And thank you. So we've got a few minutes for questions.
Do you think that these particular patterns will be integrated with Chef mainline eventually?
I can't say. So the reason why I've been doing this in a cookbook specifically is so that I can iterate much more quickly than Chef can. Certainly, I think my patterns are pretty awesome. Otherwise, I wouldn't have written them. So if other people agree with me and enough other people agree with me, I would certainly like to see them in Chef itself. That's been happening slowly as we sort of stabilize on tools. They've been getting merged, but that's not always the best thing. This recently was brought up with Chef Sugar along exactly the same lines, and the general conclusion was that there's not a whole lot of process around this, and it's unclear exactly what that would mean for either project. And so maybe it's just good to leave well enough alone. We have a dependency management framework, so it's not a huge deal to leave it externally. So we'll see. I'd certainly like the entire community get to a point where we can do that in a way that doesn't suck.
With the options collector method you had there, does that work? Does that kind of just like dump everything into a hash, or can you do any like whitelisting where like if you spell something wrong, it'll?
Nope, it's just a hash. You can actually pass either a hash or a block. So you can, it still follows the normal Chef rule, so you can define a validator function because it's using set or return like normal. So you could totally put a whitelist in there. Any other questions? All right, well.
Do you have a hit list of particular 10x cookbooks that you either like feel like are completed or?
So the two that I've published on GitHub, I can't put them on the community site due to lack of namespacing. Right. Jenkins and Rundeck are the two that I have been working on as sort of examples to guide me down this path. Yeah. The entire balanced CI pipeline is also online. That's not entirely generic. We have the CI cookbook, which is semi-generic, and balanced CI, which is super opinionated, but they are open source, so people can check them out if they would like to see sort of how to do the full cycle of escalating abstraction. But really the only low-level ones I've gotten that I'm relatively happy with are Jenkins and Rundeck.
When you were reviewing Poise service, you said run it?
So run it is the really common thing that most Chef cookbooks use, mostly because I think it's popular in the Ruby community. I'd never heard of it before dealing with Chef. Maybe you meant please run?
No, I just don't know what run it is.
So run it is a service management framework similar to Upstart or systemd or whatever else, supervisor. It's a way of keeping a process running. It's super simple and mostly undocumented. Good solid neckbeard software.
Just the way we like.
Anyone else? All right, well, thank you very much for coming.